So you need not worry whichever class you belong to, but
Sir,
whoever are,
Saturday class is there yesterday.
yeah, we have classes on Saturday and Sunday. So before I just begin, let me just know who has seen the videos of the previous lectures. So some students came yesterday saying that they are new to the class. So I just want to get a number of
Sir,
has seen the videos.
sir, we are getting the disturbance. Tell everybody to unmute.
Okay,
Mute.
yeah. So we'll just mute everyone, and I want to know whoever has whoever is coming to the class for the first time. Can you let me know that by chat? Please put your comments on the chat if you're coming for the first time to this class. So I don't see, yeah. So I can see Mahindra. Are there anyone else? So I can see 3 students who have responded. So you are new. Okay. Yeah, I can see a few people. So again, this is a repetition of what I'm saying yesterday. So please go and watch the previous YouTube videos to get a hang of what the Vedic mathematics class is all about. So we'll be touching a few concepts that we covered in the previous class, but there are many students who have been attending it for the previous 8 lectures. So considering that, I'll not go into detail of whatever we dealt in the previous classes. Okay. So today's lecture is titled The Power of Negative Thinking. So often you might have heard from your parents that negative thinking is not good. But in mathematics, you will see that there is a lot of good things about thinking about negative numbers. We are not thinking negative, but we are thinking about negative numbers. And we'll see in detail how these negative numbers will help us increase the speed in which you can do mathematical problems, especially when it comes to competitive mathematics. So today's first slide is going to be a fun exercise. All of you might have done some drawing, isn't it? Did you ever care about how much mathematics is included in a art form or a drawing? So today we are going to measure how we can do drawing using mathematics. So this is starting with what is called as the Vedic square, and we call this as number art. So on the left hand side, you can see numbers 1, 2, 3, etc. up to 81. Now, what does this represent? This is a multiplication table. So you can clearly see this is 1 times 1 is here, 1 times 2 is here, 1 times 3 here, 1 times 4, etc. Comes to the 2's table, 2 times 1 is here, 2 times 2 is here, 2 times 3, 2 times 4, 2 times 5, etc. 2 times 9, that is 18. What about the last row? 9 times 1, 9 times 2, 9 times 3, 9 times 4, etc. up to 9 times 9. So what you can see is a table of multiplications. And on the right side, you can see each of these numbers are only between 1 and 9. So yesterday we were dealing with what is called as a digit sum. So I am taking this opportunity to explain digit sum once again to the new students. So take a number like 14. Do you see the number 14? So digit sum of 14 is 1 plus 4, which is 5. You can see that in the right square here, which is 5. Now take 18. 18 has a digit sum 1 plus 8, which is 9. Let us take some more complex ones. Let us take 49. What is the digit sum of 49? 4 plus 9 is 13. But note that 13 is a 2-digit number. We need a number which is less than 2-digit, or a single digit number we need. So you have to add the digits of 13, which is 1 plus 3, and hence it is 4. You can see 4 in this square on the right. Now we are going to do some artwork. You can see the right side square. What I'm going to do is I'm going to connect all the ones. So if I connect all the ones, let me see what will happen. You can see this particular shape. It doesn't represent any figure, but nonetheless, it gives some shape. So you might recall how you might have learned to draw the shapes of different animals or different sceneries using joining of numbers. So here is a similar art form that you will get from what is called as the Vedic square. This we call it as a Vedic square. Okay, let's connect all the twos. So when we connect all the twos, we get some other staircase kind of function, staircase kind of drawing. But this is an inverted or a slanted staircase. We can also connect in different ways, and this I'll show using nines. If I'm going to connect all the nines, I can form skyscrapers like this. So you can see there are a lot of nines. I have combined all of these nines and formed skyscrapers. So now we are going to do a little bit more advanced art, and this is using this Vedic square, which is the numbers represented from 1 to 9, and it is representing what is called as the digit sum of the multiplication table up to 9. Is that clear? So I think we can proceed again. So what I am going to pick up is one particular row of this Vedic square, and I'm going to pick this row D. So the row D is having numbers 4, 8, 3, 7, 2, 6, 1, 5, 9. Now what I'm going to do is I'm going to start drawing such that the length of all the drawings are according to this measurement. So you can see how carpenters take measurements, isn't it? So you take some measurement, you cut your wood at that particular point. Then you take another piece and connect it at the end. So we are going to do a similar operation. So first we are going to draw the 4 centimeters. Let us talk about units as centimeters. So 4 centimeter line is here. I have drawn it towards the right in a horizontal manner. Now next, I will draw a perpendicular line which is in the vertical manner, which is of length 8. So I'll get something like this. Now, as the figure progresses, you will see a pattern and you will see a nice artwork that is coming up. So again, I will rotate by 90 degrees towards the left and draw 3 centimeters. Again, rotate by 90 degrees towards left, 7 centimeters, then 2 centimeters, 6 centimeters, 1 centimeter, 5 centimeters, and then last one is 9 centimeters. So this is only part of the artwork. We are going to complete the picture. The whole idea of Vedic mathematics was to complete the picture. So I can repeat this operation once again and I'll get the following. So you will see new figure appearing. And it is a repetition of the same numbers 4, 8, 3, 7, 2, 6, 1, 5, and 9. Again, repeat the same operation. You will get yet another figure. And the fourth time we repeat this operation, we get everything that is connected. So this is the nuance of Vedic mathematics. You can see we have populated the numbers from 1 to 9, and using this 1 to 9 and repeating it 4 times, we could get a closed figure. Can anyone think of why we got this result? Can you understand how we got this result? We are reaching the same point where we started. We started from this point and we ended up in the same point. So this is a particular property of a digit sum. This will happen for any particular row that you take. Okay, you can try these at home. So I'll just post this Vedic square in today's assignment, and you will be given a chance to draw these measurements on a piece of paper, and you will be able to upload your answer or the art in practically app. So kindly look forward for this assignment after this lecture. So this is just a warm up to motivate you how art forms are really connected to mathematics. Now let us go into some substance, some solid stuff, and that is subtraction. So yesterday we saw how to do subtractions, how to check subtractions using digit sums, how to do longer subtractions. So today we are going to understand a little bit more on speeding up subtractions. Most of the students do not like carries. So we are going to use what is called as a negative thinking idea, which we call it as bar numbers. So let us understand what are bar numbers. So bar numbers are nothing but these numbers with a bar on top or a line on top. So what does this represent? So the number 72, for example, can be written as 70 minus 2. So the normal number 72 without any bar is written as 70 plus 2. You will always use the plus sign. Now in the bar numbers, whenever a bar appears, a line appearing above the number, you should subtract that number. So this is the number 68. What about 861? This is nothing but 800 plus 60 because there is no bar above 6 minus 1. This is 859. What about 1272? This is straightforward, isn't it? This is 1270 minus 2, which is 1268. So we have learned a new way of representing numbers, what is known as bar numbers. Now, I want to take 1 minute and I will ask you to reply on chat. What is the bar number equivalent of 117? I'll give you 30 seconds to answer. You can put the answer in the chat. What is the bar number representation of 117? I am getting a few answers. Yes, Suhas, you have answered correctly. Yes. Yes, Krish, Mahendra, correct. Chandana, very good. So let me explain that. So 117 is equivalent to writing 120 minus 3. 120 is considered as the local base. So there are two concepts here. What is the base? Base is a number that is closest to the tens multiple. So 120 is a number which is closest to 117 and is a multiple of 10. So 120 minus 3 is going to give 117. So this is equivalent to writing 123 bar. Now the next one, what is the equivalent of 570 in bar number representation? I'll just see the chat box. What is the bar representation of 570? Somebody says 570 itself. Okay, that is also fine. Okay, but you can write it in different ways. You could have written this as 6, 3 bar and 0. Now we have not seen a bar except for the last digit, but you can also put a bar number in between any digit. So this is equivalent to 600 minus 30 plus 0. What about if I want to represent some number like 1, 3, 4? How do I write the bar number representation? There are multiple ways. One way is to write this as 1, 4, 6 bar, or I can write this as equivalent to 2, 7, 4, but a bar over 7. How do I convert this? 200 minus 70 plus 4. This is also equivalent to 134. So We will be using this bar numbers very frequently for doing subtraction. So let us go deep into this idea of bar numbers for subtraction. Here I'm going to give you some medium level subtraction, mostly 4 digits. So how do I use bar numbers? In bar number representation, you need not care about the carry. That is the advantage. So you can just do subtraction as it is. 7 minus 3 is 4. 3 minus 7. Actual subtraction would disallow such operations. But you can do in bar numbers, you can represent it as 4 bar. 3 minus 7, you do 7 minus 3 and put a bar over that. 1 minus 6 is nothing but 5 bar. And 2 minus 5 is nothing but 3 bar. But do not leave your answer here. You have to find the correct representation as an actual number. What will be that? So this is going to be 4000 minus 400 minus 50 minus 3. 4000 minus 453. That also you can do. So yesterday we have learned how to do 4000 minus 453. So can you just spell out the answer in the chat box? What is the sutra that you will use? Yes, it is nothing but all from 9s and the last from 10. So the first digit you have to subtract 1 from that. That will be 3. And the remaining numbers you can do all from 9s, last from 10. So this is going to be the answer. So let us go to yet another exercise. Here we have a 3-digit number. So let us write the bar number representation first. 9 minus 4. We are starting from the left. Remember, in Vedic mathematics, we always start from left. 9 minus 4 is 5. 0 minus 4 is 4 bar. 5 minus 7 is 2 bar. This is equivalent to writing 500 minus 42, and we know all from 9s and last from 10s. So this is 4, 5, 8. Isn't it very convenient? By using bar numbers, we are just able to do subtractions just like doing additions. So here is a 5-digit example that is coming up. 6 minus 2 is 4. 4 minus 8 is 4 bar. 3 minus 6 is 3 bar. 3 minus 5 is 2 bar. And 2 minus 5 is 3 bar. We have got a very nice expression here for doing all from 9s and last from 10. 4323. Can somebody post the answer on the chat box? So this is nothing but 3, 5, 6, 7, and 7. So indeed very quick. And all this can be done in mind. So we are going to make this practice in the mind. So I'll give you some more practice exercises below. Let us see if you can solve it. So here is the first practice. This is a 5-digit number. Let's do this. First, the bar number representation. This is 4. This is 7 bar. This is 4 bar. This is 2 bar. And this is 1 bar. So let's do this on the mind. 4 followed by 4 zeros minus 7, 4, 2, 1. So this answer is going to be 3, 2, 5, 7, 9. All of you getting the same answer? Very good. So let us do one more, and the last one I leave for you. 811 minus 345. Bar number representation would give 5, 3 bar, 4 bar. So this is 500 minus 34, which is 4, 6, 6. Okay, very good as of now. And this last one is a practice at home. So you can see the slide when you complete the lecture today. Let us do a word problem now. So some of the students are new. So let me explain what is a word problem to them. So word problem consists of some sentences to describe about the problem. and it will give you the details in between. So you have to carefully read the problem first before you attempt the problem itself. So here we have a word problem which is connected to subtraction. So Mia and her mom. So Mia is a small kid and she is playing with the toys. So after the play is over, her mother is picking up the toys and is putting it into a box. But Mia is very clever. She is picking some toys out of the box to make her mother's job little bit difficult. So the goal here is to find how much time Mia's mother will take to put all the toys. There are 30 toys. All these toys has to be put back into the box. So let us read this question so that the students will get an idea about how to read questions like this, worded problems in the future. So let us start from the first sentence. So Mia is helping. So helping is within quotes. She is doing some nuisance there actually. Her mom pick up 30 toys. So there are 30 toys which are lying on the floor. Mia's mom manages to put 3 toys into the box in every 30 seconds. So in half of a minute, she can put 3 toys into the box. But each time after 30 seconds, Mia will pick up 2 toys out of the box and put it again on the floor. Now you have to find what is the total time taken by Mia's mother to put all the 30 toys in the box for the first time. That means you have to find the time taken by the mother to put all the toys for the first time onto the box. So let us see a pictorial representation. You can imagine all those figures in the left side to be toys that are on the floor, and you can see a box that is on the right hand side. So what is the mother doing? She is picking 3 toys and putting that into that box. And what is Mia doing? Mia is picking 2 of these items and putting it again back on the floor. So the net number, what we call it as the net number of toys going onto the box. Going to the box is nothing but 3 minus 2. 3 toys are put into the box, 2 are coming out. So this is 1 toy per every 30 seconds. But you have to remember that you have to find in what time 30 toys are in the box for the first time. That first time is a very important keyword. So let us see after 30 seconds. So time is here. 30 seconds time, what will happen? How many toys have gone inside the box? It is 3. After 60 seconds, what will happen? Mia's mother has put totally 3 plus 3, which is 6. But Mia has picked up 2 plus 2 during that time. But we won't include the last 2. So it is 6 minus 2, which is, what is 6 minus 2? It is 4. So like this it will go. Till what time it will go? Till say 270 seconds. How many will be there? Till 270 seconds. Why 270 seconds? Because we can see that there is totally of 1 toy per 30 seconds going in. So if she does this 27 times, you will get 27 toys inside. Isn't it? Because net number of toys going in each time she is putting is 1. So you can see 1 is going on. Now that means that at the end of 270 plus 30 seconds, which is 300 seconds, she is going to get all the 30 toys into the box like this. So all the toys have got into the box at 300 seconds. So how much is this in minutes? How much is this in minutes? So this is nothing but 300. Oh, actually we have done, yeah, so this should not be right. So we have done a small mistake. So 27, this is corresponding to 27 times 30. So let us correct that mistake here right away. So this should be 27 times 30. So after 27 into 30 seconds, 27 toys are there. And after 30 more seconds, which is 28 times 30, you will have 30 toys all onto the box. So this equivalent in minutes is 28 into 30 by 60, which is 14 minutes. So in 14 minutes only, Mia's mother is able to put all the toys back onto that box. So hope you have understood the essence of that net number of toys. That is the part where we are using the subtraction. So in the last lecture or the previous to the last lecture, we have seen a problem or a puzzle called as the save water puzzle, where you had inlet taps and an outlet tap. So the inlet tap was giving water and the outlet tap was allowing water to drain off. So the net water that is coming onto the tank could be calculated. So here a similar logic is being applied. The net number of toys coming into the box is 3, but net number of toys going out is 2. So that is why you can see this difference, and it takes a long time, 14 minutes, to clear up the floor for the first time. Okay, that was an interesting puzzle indeed. So let us go ahead. We are going to use bar numbers again for addition, subtraction, multiplication, and division. Let us see how. So for addition and subtraction, we are going to use bar numbers. Subtraction we have already seen. So an example is given here, 29 plus 48. You can write it in a different manner. 29 can be written as 3 1 bar. Why? Because this is 30 minus 1, same as 29. And this is 4 8. We keep it intact. Now add the numbers. 3 plus 4 is 7. 1 bar plus 8 is 7, because 1 bar is treated as minus 1. Let us do this one. 623 minus 188. I want all the students to try a bar number representation of 188. What is the equivalent bar number representation of 188? Please post that in the chat. No, it is not 222. Can somebody else give an answer? I'll just wait for a few more seconds. 354. Okay, you are saying the final answer, is it? No. No. 354. So what I'm asking is what number I should fill instead of the question mark here. What is the number instead of the, yeah. So I can see 192, that is correct. 192 is correct. 192 bar. So let us fill 192 bar. Now let's do this. So 6 minus 1. What is 6 minus 1? 6 minus 1 is 5. 2 minus 9, we can write it as 7 bar. 3 minus 2 bar, which is 5. Please note that change. 3 minus 2 bar is 5. So this is 500 minus 70, which is 430, plus 5, which is nothing but 435. There is also another way of representing 188, that is 212. Put a bar over 1 and 2. 200 minus 12, that is also 188. You will get the same answer. 6 minus 2 is 4. 2 minus minus 1. 2 minus 1 bar, that is 3. 3 minus 2 bar is 5. Let's do one more. This time you have both addition and subtraction. So we'll do it everything together. 5 plus 7 is 12 minus 2, that is 10. I'll put 10 as it is because it is the leftmost digit. 0 plus 4 minus 8, that is 4 bar. 3 plus 8 is 11 minus 8, that is 3. 2 plus 9 is 11 minus 3, which is 8. So what is this number equivalent to? 10,000 minus 400 is 9,600. So this is 9,638. So you can see how even addition and subtraction can be done very quickly. Now we are going to multiplication and division. Very useful technique in this case also. So we are going to do 29 times 3. Some of the students will find multiplication with 2-digit numbers like 29 also difficult. For them, you can use bar numbers. How to do this? 29 is represented as 31 bar into 3, which is 93 bar. So what is this? 93 bar is 87. Now we are going to divide 87 by 3. You can directly give the answer as 29, but let us use the bar number representation. 87 is same as 93 bar. You can divide each number by 3, which is 31 bar. Now here is a little bit difficult one for you. 41. What is 41 divided by 7? So there is no bar number representation for 41, is it? How can you write 41? 41 is 40 minus 1, or you can write 59 bar, something like that. But here the whole idea is to remind you of this concept of remainder. So you can write 41 as 42 minus 1 divided by 7. So this is equivalent to writing 6 and remainder as 1 bar. So what does the remainder 1 bar mean? Remainder 1 bar. Remainders are usually not negative. So 1 bar here represents 7 minus 1, which is 6. So the actual remainder when you do 41 divided by 7 is 6, but you can represent that as 1 bar. So we will take more advanced methods using bar numbers for multiplication and division in a later lecture. So for the current lecture, we'll stick on to this subtraction alone. Now we are going to a very interesting topic. So we have learned about addition, subtraction. Now in paper, is it possible to just do addition and subtraction just by looking 2 digits at a time? So this is what is called as number splitting. Very important concept for speeding up your problem solving. So I'll just introduce this example. I'm doing subtraction here. So what I need to do is I want to do this subtraction very quickly, but I only know about 2-digit subtraction. So what I can do is that I will put a partition around these numbers. 908, I'll partition between 0 and 8. 456, I'll partition between 5 and 6. Now I can consider this as separate numbers. 90 minus 45 is 45. 8 minus 6 is 2. So you can see how speed increases. How will you do 8393 minus 2865? Again, put a bar here or a number split. You can do 93 minus 65. What is the easiest way of doing this? 90 minus 65 plus 3. 90 minus 65 is 25 and plus 3 is 28. 83 minus 28 is nothing but 55. These are all 2-digit numbers. By now you will be able to do 2-digit numbers easily. Other way of doing this is 83 minus 30 plus 2. 83 minus 30 is nothing but 53, plus 2 you have to do because this is 28. Let's do one more. This is a 5-digit number. Usually it is very hard to do 5-digit numbers. So let's partition here. This is a easy split. 64 minus 38 is nothing but 26 here. What about 935 minus 657? Is it easy to do? This you can do using normal bar numbers, which is 3, 2 bar, and 2 bar, which is this 300 minus 22. All from 9s, last from 10. This is going to be 278. So the answer is 26278. So how wonderfully you can complete the subtraction using number splitting. Now in the practice, I want you to tell where to put the split. I'll look on to the chat for a few seconds, for maybe 30 seconds. You have to tell me what is the split that I should use. Where should I put the split of the numbers? There will be multiple answers, of course. Okay, somebody is, I think, telling the answer as it is. No, okay. Somebody said hundreds place. Let us try hundreds place here. So after the hundreds place, let's put here. So 81 minus 47, this is going to be 34. 613 minus 487. You use the bar representation. So this is going to be 2, 7 bar, and 4 bar. So 200 minus 74, which we know how to do, 1, 2, 6, 3, 4. This is equivalent to this. I will urge you to practice the remaining questions at home, and I'll just take number splitting for addition. So you are all familiar with the number +91 appearing before the mobile numbers. And you will also be familiar with the state codes. Each state has got some code. Code meaning some states, for example, Delhi has 011 as a code. So these are representing some areas. So similarly, if you split the numbers, it represents what? The place values. So usually you will be only required to give an approximate answer in some certain cases. Suppose you have gone to a shop and you have started bargaining. You are only bothered about the approximate cost, not the exact cost. So number splitting is very useful in that situations as well. So let us do these problems. We are going to split the numbers and do addition. So easiest split is 2 digits like this. What is 67 plus 28? This is nothing but 95. 38 plus 44. What is it? It is 82. So you can get the answer very quickly. What is 619 plus 135? What is the split that you have to choose? Let us choose like this, 7. What about 19 plus 35? You can do 20 plus 35 very easily. Subtract 1 from that. So this is 54. Here is another one. 5659 plus 5926. You can split here. What is here? This is 94. This is nothing but 85. What about this one? Similar technique goes 46, 59, 28, 76. 46, 28, you can do 30 plus and then minus 2. What is this? 74. You can add 60 first, then subtract. So you should be careful about a carry. What is the carry coming? So 136. So you will write 36. 1 is a carry, so you'll write below. This is 7536. Okay, so we are ready to go further now. One more last problem. 3684 plus 4738. Let's do the same thing. What is this going to be? You can add 50 and minus 3, which is 86 minus 3, 83. This one you can add 40 first and minus 2. So that is going to be 124. Minus 2 is 122. The 1 I'll write below, indicating the carry. So this is going to be 8422. So this is how we are using number splitting for addition. So there are techniques for doing number splitting for multiplication. I will just briefly touch upon this. We'll encounter more examples in the future. So here is an example. You want to double the number 352. So what you can do is number split 352 is 35 and 2. You multiply each of these splits separately by 2. You will get 70 and 4, 704. Let's try this. 726. Number split is already given for your convenience. So this is nothing but 21. What is 26 multiplied by 3? This is simple because you can split this as 25 plus 1. 25 into 3 is 75. So you have to add 3 more, which is 78. So this is 2178. How do you split this? Is there any way of splitting this? You can do split like this. Double of 38, that is 76. Double of 27, that is 54. You can see how quickly the answers come. Here is a very interesting one, which is a multiplication by 5. Somebody recalls how we did multiplication by 5? One way of doing this is 3623 into 10 by 2. Multiplication by 10 is very easy, isn't it? So this is 36230 by 2. So half of this you have to do. Now halving operation also you can do very easily by splitting. So this is nothing but 18. Half of 230 is 115. So you can see how quickly we can do these operations just by using simple techniques available in Vedic mathematics. Here are some practice problems. You can try these at home. I will just skip the number splitting for division and explain to you the puzzle for today. I will retake this topic of division, and there is a well-known technique called as divide and conquer. So you can see previously kings used to conquer different places, different kingdoms using this approach. They would divide the people in that kingdom and they will conquer that particular kingdom. So you can use this in a positive manner for getting your solutions in a quicker speed. So today's puzzle is very nice. It is called as the rabbit and the carrot. Okay. So let us see what this puzzle means. So there is a rabbit who is trying to get a carrot, but this carrot is not very near. Carrot is very far. You want to estimate how much time the rabbit takes to reach the carrot. So here is this problem. So there is a pet, Zeno's pet. He jumps halfway to the carrot. Suppose the carrot is placed somewhere here, and here you have rabbit. So there is a distance between the carrot and the rabbit. So what the rabbit does is that rabbit jumps halfway to the distance between the carrot first. Now, from there, he again takes a half distance like this, again half, and when he reaches almost very close, what is that closeness? That is 6 inches. If he gets to 6 inches within the carrot, he will take it and eat. Now, suppose initially this distance was 12 feet. So feet is a unit of measurement, just like meters, centimeters. Feet is a unit of measurement. So 1 feet is equal to how many inches? 12 inches. So 1 feet is 12 inches. So you can use this conversion to find how many times the rabbit has to jump. In this figure, I have represent 1, 2, 3, 4, etc. So you have to estimate how many times the rabbit has to jump. So this is the puzzle that will appear after today's lecture. So you can try to solve that at home. Okay. So before I end, I would like to tell this announcement. So the announcement is that every lecture will be followed by 1 or 2 puzzles. So that will appear in your Practically app, and you can open the app and try to solve these problems. You will be given a day or two for solving the problems. Think carefully and answer. And if you have solved the problem, try to see the solution, because solution will give you an explanation about how you can do the calculations faster. And it will also verify whether your solution is right or not. And that is the announcement 1. The announcement 2 is the following. Every week you will be having what is called as a practice quiz, practice set or a practice quiz. You will have a set of 10 problems that will be appearing, and you can solve these are subjective problems. You can solve it on a piece of paper, scan it with your mobile or tablet, and then you can put your answer in the Practically app. I'll give you feedback whenever possible. Okay, so with these two announcements, I will like to open the floor for questions. Now you shall be able to unmute yourself and ask your questions.
Sir, how can we send my answers in a paper?
Yeah,
So-
sir. How can we say?
Yeah. So in the Practically app, for subjective questions, you can just open the solution part and just scan your solution there. There will be option. So if you face any difficulty, you can put a mail to the Practically team. Somebody will be able to help you.
How, sir? How can we mail?
So you can see the email address within the Practically app itself. So if you are not getting, please ask your parents to help you in figuring out how the mailing can be done. Yeah.
Sir,
Yeah, please go ahead.
can you please tell bar subtraction, sir?
Okay. Before that, I would like to know if there are some other problems also.
Yes, sir.
Yeah, please ask.
Vedic,
Sir, we learned about
Yeah, one at a time. Maunika, you can ask.
Vedic square, sir. Can
Okay. Okay. So let me explain that. So till that, I would like to mute you all. Let me go to bar numbers first. Okay. Okay. So bar numbers, I hope you have understood. So 72 bar is written as 70 minus 2, which is 68. Now we are going to use this for subtraction. I will just explain it with this example. 7312 minus 3765. So 7 minus 3, which is the larger number? 7 is the larger number. So you can do this subtraction correctly, because always when you do subtraction, you look whether the number that is appearing first is larger than the second. So 7 minus 3 is possible, and you will get the answer as 4. But look at the second largest place value, which is 3 and 7. 3 minus 7 you cannot do as per normal subtraction. So what you have to do is that you have to represent it as a bar number. That is 3 minus 7. You can do 7 minus 3 first and put a bar over the top of 4, which is 4 bar. Similarly, 1 minus 6. You do 6 minus 1, which is 5. Put a bar on top. Is that understood?
Yes, sir.
Yes, sir.
Okay. Now I'll come to
Understood, sir.
Sir.
yeah. If there are any questions related to bar numbers, I would like to take that now. Yeah.
How can we know which place would we slip the number in subtraction, sir?
Okay.
Split the number in subtraction, sir.
So there is no one right way of doing that. Wherever you find it convenient to do the splitting, you can do that splitting wherever you like. So there is no one correct answer.
Sir, Vedic square.
Yeah.
Okay, sir.
Okay.
Okay,
So
sir.
let me let me go to the Vedic square. So you can see this Vedic square, how we have formulated. Let us go here. Okay. So,
can we leave? Sir,
yeah. So kindly wait for 2 minutes. I'll just explain the Vedic square and then you can leave. So Vedic square is formed as follows. So on the left side, you see a multiplication table. So this is a multiplication table. If you see this carefully, you can observe that. How is it a multiplication table? See the first row. This is 1 into this, 1 into first row. If you do 2 into the first row, you will get the second row. If you do 3 into the first row, you will get the third row. So similarly, if you do 9 times the first row, you get the last row. Now pick up each number. In the first row, you have only numbers from 1 to 9. So what you have to do is 1 to 9, the digit sum is same as 1 to 9 itself. The digit sum does not vary. But for numbers like 10, you know digit sum is 1. For 12, the digit sum is 3. So in the Vedic square, I am only going to write the digit sum of the numbers on the left hand side table. So this is how I get the Vedic square. Is that clear?
yeah, sir. Sir, for first to 10th classes, this one class only, sir.
I didn't understand the question. Is it a question or a? I will.
This is 9th lecture, right, sir?
Yeah, this is the 9th lecture.
Excuse me, sir.
Any class members can listen this class, sir. Every
Yeah,
class members.
so this is what I was explaining. Yeah, this is available for free on YouTube. So you can see the previous lectures if you have missed any. So
Not
go
like
and watch that in the YouTube Practically channel.
Excuse me, sir.
Yeah.
Sir, so we learned about number splitting, right, sir? Means
Yes.
if we get any large number like 6-digit number, so should we split only one time or how many times we want we can split?
Yeah, you can split it into any number of times. But suppose you are comfortable with 2-digit addition. It is convenient
Yes, sir.
to split. It is convenient to split as 2, 2, 2.
Yes, sir.
Yeah, suppose you are very much expert in 3-digit addition, then you can also split it as 3 numbers and 3 numbers. So
Okay,
it is
sir. Thank
according
you.
to what level you are in.
Okay, sir. Thank you, sir.
Yes,
Okay, so I would like to conclude today's lecture. I want all of you to look into the Practically app and see if you can solve the puzzle by yourself.
Okay, sir.
So with that, we end for today. See you next Saturday.
Sir, I
Thank
think
you.
it's
And
Thank you, sir.
because literally half the day. Bye.
Have a nice day, sir.
Bye, sir.
Thank you, sir.
Have a nice day, sir.
Bye, sir.